Atomic emission spectroscopy is the procedure of analyzing chemicals that employs the intensity of light from a flame at a definite wavelength. The most common method of measuring atomic emission spectroscopy is the flame method. In this method, a sample of material is to be analyzed and brought into a flame in the form of a sprayed or chemical solution. Free atoms of the material are produced when the flame evaporates, causing a certain visible spectrum color that can be found on the visible spectrum of wavelength. The solvent breaks chemical bonds into the analyte. The heat also changes the atoms into electronically charged particles, also known as photons, which emit light when they get back to the ground electronic state. Light is emitted at a wavelength characteristic to each element, which is then dispersed by a prism and viewed through a spectrometer, whether it be cylindrical or pyramidal. The atomic spectral line identifies wavelengths of photons and light intensity and is proportional to an atom count. So for instance, if you look at, say, a solvent A doesn't have as much atoms or atom vibration and energy as compared to solvent B. So solvent A is in the 500 to 550 range, and it'll yield a green flame. Solvent B has slightly more energies and a higher intensity, so it'll be in the 600 range. Solvent C finally will be in the high 650 range, going up towards 700. So what this means is the higher the energy level, the more the movement in the atom. This movement is also seen as heat, and then therefore it changes and applies to color. So solvent C proportionally has the most atom energy. Solvent B has the second most solvent energy, and solvent A has the least. The spectrum ranges from violet to blue to green to yellow to orange to red. If you look at the polar sides of the spectrum, you got ultraviolet waves, which are often seen in low intensity lights such as the sun or fluorescent light bulbs and tanning beds. On the other hand, infrared shows the most intensity and the most heat signatures. This can be seen with infrared goggles or high energy telescopes. In conclusion, once again to restate, how did this shows energy levels in the atom? It shows that proportionally more atoms yield a certain heat color, or certain fires yield a specific color. This meaning solvent C has higher levels of wavelengths in nms. Solvent B with the second most, and solvent A once again has the least.